Cool. Thank you everyone for being here. This is managing your cloud native applications with blob storage. So we have a lot to cover today in just 20 minutes. We're not going to be able to cover everything, so please feel free to see me after this session or meet us at the hub to discuss and ask more questions. So in this session, I'll briefly go over blob storage, then I'll go over some of the features that we launched in the past year, as well as some upcoming features. And then I'm also going to show a quick demo of a feature that I'm really excited about. So blob storage is Azure's object storage platform. It's one of the core foundations of Microsoft and the cloud. So pretty much all of Microsoft services and Azure use some type of blob storage on the back end. OneDrive is built on top of blob storage. Blob storage allows you to store exabytes of structured and unstructured data. So you can store anything from application logs to videos and images to application backups. And because it's such a key part of Microsoft's cloud strategy, it has broad integrations across all of Azure services. So once your data is on blob storage, you can really unlock the power of the cloud and extract value from your data by leveraging other Azure services. So blob storage, we want you to store your data and not have to worry about the complexities of managing data storage on the cloud. So that's why we focus on 5 pillars. The 5 pillars we focus on are durability, which allows us to store your data and ensure it never gets corrupted or lost. So you have your options of durability, and we'll go into that a little bit later. Security is a huge aspect of the cloud. You want to make sure your data is secure in the cloud, it's encrypted, and only your users and applications that can access it are the ones that are accessing it. And the main part of this talk, manageability and cost efficiency. You want to make sure your data on the cloud is manageable, you're using it in the most efficient manner, and you're not building things on your application side that are already covered on the service side. And of course, the last two, open and interoperable and scalable and performant. We want you to be able to build your applications using the best languages, the best tools, and best partner solutions, and not have to worry about that. And of course, it has to be scalable and meet the requirements of your applications and your users. So we're going to go into durability first. As you may know, Azure Storage has many durability options. The first one being single region, locally redundant storage. 3 replicas of your data are stored in a single region. This protects against node, disk, and rack failures. So you have to worry about storing 3 different copies and 3 different storage accounts or stuff like that. We'll handle it for you. Another single region replication option is zone redundant storage. This takes advantage of availability zones within Azure. So your data is stored within a single region, but in 3 different availability zones. So these availability zones have different power, cooling, and networking. So if any one zone goes down, your data is still available, and your applications see no downtime. And then we have dual region options like GRS, which is basically 2 LRS regions, typically over 300 miles apart. So you have your primary region and your secondary region. You have 3 replicas in your primary region, and then they're asynchronously copied to the secondary region 300 miles or greater apart. And RAGRS is basically GRS, but you have read access to your secondary endpoint. And then within the last year, we also launched GZRS and RAGZRS. So these are in public preview right now. GZRS is geo-redundant zone replicated storage. So your primary is taking advantage of ZRS, where you have your 3 replicas stored against 3 different zones, protected against node, rack, and zone failure because they have separate cooling, power, and hardware. And RAGZRS is of course, secondary on the reads. And then I'm going to talk about a new feature that's coming up soon. This is called object replication. So this allows you to define a policy to replicate your objects to any region and any storage account of your choice and in any tier of your choice. So this allows you to reduce latency for your applications by providing local access in each region. Some of the requirements of versioning and change feed, I'll go into that a little bit later. So in this example, I have account 1, which is an LRS premium tier. Data is coming in. I want to replicate that to another storage account in the cool tier. So I can set up a replication policy using prefix on the blob name or tags and replicate it to a secondary account that's LRS in the cool tier. So I have the second account. I can use it for dev test scenarios or A/B testing. So let's say your application now is a global application. It really blew up in India. So I want to replicate my data to a secondary region in India. I can also set up another policy to do a cross-region replication to a hot GRS account. And then lastly, I also have to make sure my data is secure and compliant. So I'm having a durable replication of all my data in an offline tier. So I set up another policy to replicate to a third storage account in the archive tier in a third region. So you can see how using the built-in replication systems like LRS, ZRS, and GRS, you're protected against data corruption and failure. But here you can also set up your own policies to meet your own application requirements, such as lower latency, higher redundancy, and also compliance needs. And then I'm going to talk about security and compliance. Azure wants to ensure your data is secure, so we provide many different encryption scopes, one of which is Microsoft Managed Keys. You can make sure your data is securely encrypted at rest with Microsoft keys, or you can provide your own keys on Key Vault. And lastly, you can also provide your own keys on upload through your own on-premise Key Vault or a third-party key store. So every upload, you're indicating your encryption key, and every download, you're also indicating that encryption key. So no one else can get that data unless they have that encryption key, and you can manage that encryption key on your own on-premise server or in another third-party key store. And lastly, Azure Active Directory identities and role-based access control. This ensures that only the users that you specify have access to your data, and this provides just-in-time access and ensures also your applications are the only ones that have access to your data. So you can set up a VM, give it a managed service identity through AAD, and ensure only that VM has access to your blob storage account. You don't have to worry about giving it the account access keys or tokens or rotating them. It's all handled through AAD. And then in terms of compliance, this is a really hot feature for financial services, healthcare, and also other application critical workloads. Immutable blobs provides worm protection for your data. Worm is write once, read many. So this prevents you from overwriting or deleting your data when there's a policy locked against it, either a retention policy or a legal lock policy. So for regulatory compliance like SEC 17A4, you have to keep your financial records for 7 years and make sure they're compliant and immutable. You can set a immutability policy on your data for 7 years, and in that 7-year time frame, no one user or no application can delete that data, and that ensures you have a tamper-proof, compliant data storage. And your immutability is retained even with data tiering. So your data comes into hot for the first 30 days, and then after a month, it goes into cool, and after 6 months, it goes into archive. Compliance is retained while you're moving between the different tiers of Azure storage. So that's just some of the ways you can set up a immutability policy on Azure Portal. And then finally, the meat of this presentation, manageability and cost efficiency. So I talked a little bit about the tiers, and I just want to go into a little bit more depth on that. Premium tier was a new tier that we launched last year. This provides extreme low latency by using SSDs to store your data. So this is really good for high transaction workloads or applications that are really latency sensitive. And then hot and cool tiers are stored on HDDs. These still provide immediate access with millisecond latency. And hot is more used for data that you're frequently accessing, and cool is data that's like been there for about a month. You want to tier data from hot to cool. And then afterwards, you can store that for long-term retention in archive with hour-long offline retrieval latencies. And then the price goes from the highest for premium to the lowest for archive, with archive being $1 a terabyte per month of storage. And then just a few months ago, we launched some access tier and API enhancements. We're allowing you to write directly to any tier of your choice. Previously, you had to write into your account's default access tier and then do subblob tier to move it between hot or archive. Now you can write directly into cool or archive, even though your account is a default hot tier. So you can save money upon creation because you know exactly where your data needs to be when you create it. Secondary to this is priority retrieval from archive. A lot of you have asked, how can I get my data back in an emergency when it's in the archive tier? So archive has hours-long retrieval latency, typically around 3 to 5 hours, but you can expect up to 15 hours. But now with this high priority retrieval option, you can specify, I want this data back as fast as possible, and we'll try to return it to you in as little as 1 hour. So this is great for that emergency restore situation. There's no need to pre-purchase anything. You're still taking advantage of the archive tier at the lowest cost of the public cloud at $1 per terabyte. And then when you need it for emergency, you can restore it at a high priority. Additionally, Copy Blob now supports archive as a source. You're able to make a copy of your data in archive to an online tier temporarily. And this, you're also able to specify that you want that copy at a high priority. And there's no early deletion fee for a copy blob from archive because your source data remains in archive, but you're making a temporary copy in an online tier. And then lastly, we released a new API called Batch. This allows you to submit up to 256 operations in a single request. And this is acknowledged asynchronously, so you don't have to open multiple connections on your client to do subblob tier or delete blob. You submit up to 256 subblob tiers or up to 256 delete blobs, and we'll handle that asynchronously for you. And then lifecycle management is the ability to set rules to automate the data tiering and deletion. This is another feature that we launched within the last year. You can set up policies such that my data after 30 days, move it to cool, after 120 days, move it to archive, and after 7 years, delete it. So this policy engine runs automatically at the storage account level every day. So it's moving your data based on the age of the data into the most efficient tier for you and saving you money. And you can specify a prefix to target specific containers or specific groups of objects. And then one of the new features that are also coming out is change feed. Change feed builds upon blob events. So if you're aware of event notifications where you get a push event every time a blob is created or deleted, change feed is an ordered list of those events stored within your storage account for you to process asynchronously at your own time. So if your application is heavily transactive and you don't want to get millions of push notifications every minute, you can batch process them at your own time every 10 minutes or every hour. So this is a great scenario for you to handle like change tracking. So you just process the changes from when you last left off at the last checkpoint. So you don't have to go and constantly scan and list blobs and check for the blob properties creation date. You're just consuming the change feed from the last checkpoint and only paying for what you consume. So this is one of the features that is required for object replication. Object replication will build upon change feed to replicate your data to secondary regions. And then object versioning is another great feature that's been requested. Previously, we have snapshots where you can manually create a snapshot before you write. This creates a point-in-time copy of your data. Then we also release soft delete, which protects against accidental or malicious deletes by creating snapshots for you on the back end upon deletion or overwrite. But now with versioning, you're able to upload the same name, same blob name, but it generates a version ID. So you can have two of the same blobs, but with different version IDs. So you can actually serve them and access them independently. So versioning is enabled at the storage account level and allows you to have multiple copies of the same version, and it provides greater levels of protection because your data will never get overwritten. It'll always create a new version. It'll never get deleted. It'll always create a new version. And of course, you can manage those versions with lifecycle management, or you can manage them yourself through the application. Because it has that version identifier, you can specify your request to go and affect just that version and not the base blob. And it has new SAS and role-based access permissions, so you can specify which users are able to delete versions. So I upload blob 1. It has a version identifier, which is the timestamp at which it was created. I upload blob 1 again. I have another version ID. So both these blob1s.txt can exist in the same container on the same storage account and both be accessed independently using the version identifier. And then this is a feature that I'm really excited about that my team has been working on for over a year. It's called Blob Index, and it's auto-index user-defined key value tags for easy filtering and manageability of data. Today, when you're doing list blobs, you have millions of blobs in your storage account, and then you have to do your own comparison against the metadata or system properties. With Blob Index, you're setting key value tags, and these are automatically indexed by Azure Storage for you to consume. So you can reduce application complexity by storing your data and your data index on the same blob service. You don't have to worry about spinning up a Cosmos DB or SQL server to handle your metadata and your blob index. You set your tags on the blob on upload or post-upload, and the index is eventually consistent, but the blob's tag set are strongly consistent. So you can do a fast lookup on millions of items on your storage account in less than a millisecond. So I'd say I want to find all the blobs in my storage account that have color equals red. I'll just give it that query on list blobs, color equals red, and it'll return me just those 10 blobs out of a million blobs that satisfy that criteria. And we'll also support the AND operator for multi-tag filtering, so you can say, give me the blobs that are color equals red and classification equals secret. And it also supports other operators besides the equals operator. It supports the greater than, less than operator for lexicographical searching on strings. So we'll support existing APIs. You can upload your blobs with tags, or you can upload tags post-creation for your existing data. So this is also going to be leveraged as a platform integration feature. So data lifecycle management will also support this, as well as object replication. So you can specify which sets of objects you want to move between tiers or delete using tags and lifecycle management, or which objects you want to replicate to a secondary region using tags with object replication. So I'm just going to go into a brief demo. Second here. So it seems I'm not able to pull up my second screen, but I'll go back to the demo a little bit later. So I'll go back to the demo a little bit later if I can get the second screen working, or you can come see me after this talk or at the booth to see the demo. I'm just going to talk about interoperability. Azure Storage has tons of SDKs and APIs for you to use, as well as an extensive partner ecosystem, so you can find the exact partners for your various scenarios. And then I want to also say that Azure Data Lake Gen 2 and Blob Storage multi-protocol access is now GA. So as you may know, Blob Storage is the building block of Azure, and Data Lake Gen 2 is providing that hierarchical namespace on top of Blob Storage. This is great for your big data workloads that need to traverse a directory and have concept of file level and system level directories. Now you're able to use both the ADLS Gen 2 APIs as well as the Blob APIs to interact with your Data Lake Gen 2 accounts. And some of the enabled features we have are hot and cool tiering, SDK and tooling support, and we're also building more features to come, stuff that are in preview is lifecycle management and archive tier, with much more to come for Data Lake Gen 2. Data Lake Gen 2 will eventually support all the services and features that Blob will support. It's just going to come in phases. And lastly, I want to talk about durability, not durability, but high throughput, scalability, and performance. So you have cloud applications that are pushing the limits of your storage account, and we've built improvements on our own side such that you don't have to worry about sharding or distributing your data across multiple storage accounts or weird naming conventions. This is an improvement on our backend such that application data uploads that are 4 megabytes or less with put block is written at your account throughput limits. So you're able to write 1.5 terabytes across 4 VMs in less than 2 minutes. So how does this work? Blob storage has 3 main layers. We have the front-end servers, the table servers, our partition servers, and the stream layer. The stream layer is where your data is stored. So you're uploading a 50 gig file, and we automatically assign a unique ID to it. These go to the front-end servers, and the front-end servers writes it to the partition servers and then stores it durably on the stream layer. With high-throughput block writes, we're able to distribute your writes across all of our front-end servers, or the majority of it, such that you're able to hit your theoretical account limits and write as fast as possible. So this is great for writing a large file in as little time as possible. You can't wait, your users can't wait to upload a file. You want to make sure that they're having the best experience as possible, and we've built improvements on our own side to handle large uploads. Additionally, we're also handling high throughput block reads. Your users are constantly getting the same information from your applications, and we want to serve that to your users as fast as possible. So we've implemented 2 layers of caching, one on the stream layer such that the multiple partitions are cached into the SSD stream on the stream layer such that we don't have to go and rebuild the different blocks. Your whole object is there. And then once more applications are requesting that same object, the front-end servers also have an in-memory cache, so they don't have to go and do a lookup on the partition server. You're just serving it from the front end. So if you have tens of thousands of the same requests for the same object, we're able to serve it directly from the front-end server without you having to wait. And then lastly, this is just some of the sessions that we have for our Azure Storage Media and Edge family. I hope you go to these sessions later today and tomorrow. And there's a lot more that you can find on aka.ms/Azure Storage. It'll have a full list of our sessions as well as information on our products and partner solutions. So I'd love for you to come talk to me after this session if you want to learn more about Blob Index or see the demo or anything else. Thank you.